What's up, guys? This is Professor Spawn, and today we are going to learn about what is derivative as a concept, right? What is exactly a derivative and why we need a derivative? So, to do that, what I'm going to do is I'm going to start off with something more trivial concept, which we call it as a slope, right? So, for example, let's say that you want to calculate the slope, right? The slope of a line. So how do you calculate the slope of a line? This you have learned in your previous, maybe you have learned in high school, or you have learned in the previous classes, right? So to calculate the slope, what you do is you do delta y upon delta x. You have seen this somewhere, or maybe you have seen something like y2 minus y1 upon x2 minus x1, right? So this is basically nothing but what we call is an average rate of change, right? Average rate of change. So what is the idea of calculating the slope? What is the idea of calculating the slope? It's basically calculates the steepness of a line, right? This is nothing but the steepness of a line. For example, you have some slope that define a steepness towards downward, so that line would something look like this, right? Or the line can be going upward. So this is basically just defining the steepness of a line. So I'm just going to rub this up, and this is also called as an average rate of change, and this is you have learned about it. So for example, let's say that I'm going to draw a line here, or rather a curve, right? This is some curve, and you have 2 points here. This point is P1 and this point is P2. Okay, now let's look at, so this is basically an x coordinate, this is basically a y coordinate. So if you plot this line at the x axis, right, so this is some x, and there is one more P2, so this is P2, and this is at at distance, let's say at x2, right? So I'm going to have an x1, this is an x2, and the distance is can be anything. For simplicity, I'm going to assign it as h. So this distance is x, this distance is h, so that this total distance is x plus h. Okay, so in a coordinate system, the P1 will point to something like x1, comma f of x, f of x1, because this is a function given by y is equals to f of x, and P2 will be given by x2 plus h. Remember this, the total distance is x x2 plus h, comma f of x2 plus h. So you have 2 points, and if you want to calculate the slope, what you do is you can draw a line, so that line will join these 2 points, right? And if you notice that this line is basically nothing but a secant line, this is nothing but a secant line. So if you join these 2 points, right, so then it becomes very easy to calculate the slope between these 2 points using this formula which we have written, y2 minus y1 upon x2 minus x1. So for simplicity, I'm going to keep this as x, so this will be x, so I'm going to remove this, this will be x. So by the formula, the slope m would be f of x plus h minus f of x upon x plus h, right? x2 is x plus h here, minus here the x1 coordinate is x, right? Now if you notice, this and this get cancelled. So the slope here is f of x plus h minus f of x upon h. So this is, so what we did is we took the 2 points here, and we calculated the slope, and we found out from the basic slope formula that the slope for this graph is f of x plus h minus f of x upon h. So this is your formula. Now let's say I have a daughter, and my daughter will come to me and tell me, Daddy, you have taken 2 points. No, 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 no. I don't like 2 points. I want you to find a slope at this very specific line, at this very specific point, at P1. You have taken 2 points. I don't like you. I want to find a slope at this line. Now that's an interesting question, because she is asking me to find a slope, or rather a rate of change at this very specific point, at point P1. How am I going to do that? So to do that, I'm going to carry forward this. I'm going to create a new slide here, and I'm going to again draw that here, that function. So I'm going to point this out, and I'm going to here draw that graph overall again. So I'm going to draw it. This is, I'm really sorry, so I have to rub this up, right? So I'm going to draw this graph here. So to draw the graph, I'm going to use this line, and I'm going to draw it graph here. And I'm going to draw those 2 points, right? So this is some value. So this is P2, this is P1, and we have know that slope is f of x plus h minus f of x upon h. This was the slope, right? When you join this 2 point by a secant line, you can actually find the slope. But my daughter said that you have to find a slope at point P1. So I think about it, and one thing I notice is, as this distance is h, right? One way is not the one way, but what I can do is I can move this point towards P1, because to calculate the slope at, let's say, P1, what I can do is I will start moving this point P1. If I start moving this point P1, this h will decrease, right? So moving point P2 will decrease h. This is pretty much clear from the graph. Why am I doing that? Because if I want to find a slope at this very specific point, I will actually decrease the h such that the h will move towards zero. The difference between these 2 points will move towards zero. I can say that the h is approaching to zero, right? If h approaches to zero, so just a visualization. So at original, this is here. So if I move this point very close to here, what I can do is I'll move this point to this here, and I can move this point to here, and I can move this point very close, such that the as h tends to zero, there will be some point when you are at this point, right? So what happens is, to find a slope at this point, if I draw a line, and if you notice, if you draw a line that touches this point P1, and as the distance between the 2 point approaches to zero, you are basically touching this point. And rather, what you're doing is, as h tends to zero, it will come a point where these 2 points are almost same, right? It's right. And then you can actually find a slope at this point. And if you notice, this is a tangent. If you draw a line at this point, this is a tangent, right? So when h tends to zero, and you have learned from the limits, so h is not zero, h is very small. H can be 0.0001, even though it's infinitesimally small, but this is not zero, right? this is approaching to zero. And this is why if you want to find a slope at this very specific point, you have to have a limit, because h is not zero but it's approaching to zero. And I'll get a new formula as m, or slope, is equals to limit of h tends to 0 f of x plus h minus f of x upon h. And this will give me a rate of change, right? Rate of change at a specific point, at a specific point, or rather, this is giving me an instantaneous rate of change. Instantaneous rate of change, right? Why did we apply limits? H is not zero, it's almost approaching to zero. There will be a point when this point is are basically touching, right? Infinitesimally close. And I can say that, if I draw a line, this is basically a tangent line, right? And now I already know the formula for slope. So what I did is I applied this limit. So by applying this limit, I'm actually calculating the approximate value of slope at this point P1. So, so basically, in short, I am finding the slope at this very specific point, or rather, I am finding the instantaneous rate of change at this very specific point, and this whole concept is called as derivative. This is a definition of derivative, right? So a derivative gives you an instantaneous rate of change, or a derivative means a rate of change at this very specific point. Now, if you calculate the derivative of this function, right, y is equals to f of x. Now, if you want to find a slope at this point, just put the value of whatever the x here inside this function, apply limits, and you will find the slope at that very specific point. This is the whole concept of derivative. Is basically you are finding a slope between these 2 points, but if you want to find a slope at that very specific point, or if you want to find the rate of change of a function at a specific point, you can do it by applying limits to the slope, and that concept is called as a derivative. I hope you understand this concept, because this is very important and this is fundamental to calculus. And Newton was one of the first one who had this derivative concept, but Leibniz, this formula is actually developed by I mean Leibniz. I don't know, you can confirm this. This formula is given by Leibniz, and Leibniz actually defined derivative. So Newton and Leibniz, like both worked independently, and they developed calculus. So the first one was Newton, who come up with the calculus concept, and Leibniz used some of those concepts and define some of the new calculus concepts as well. So you can read about the historical evolution of calculus on Wikipedia, a lot of things. But the point of this tutorial is to understand the concept of derivative, right? So in the next tutorial, we are going to see some standard function and their derivative using this formula. And I'm very hyped for this course. I hope you like this, and if you have any issues, doubts, you can post in comment section. I will be very happy to answer those questions. Till then, goodbye and see you in next tutorial.